Welcome to this week's midweek space news. So I'm just going to round up some space news articles I found on social media and on websites. If you have an X account, you can follow us at Space Startup Hub. So with that, let's get on to the first story of this week, and that is on RFA. So they posted on their X account an update on their RFA ONE rocket, and they posted a few photos. We'll have a look at those, and then we'll read the press article on RFA's website. So first of all, here are some photos, and you're looking at the first stage and the second stage of RFA ONE. This is an orbital class rocket that will be launching from Saxavord Spaceport in Scotland. They've tested and qualified the first stage and the second stage. They're currently working on qualifying all the 9 engines on the first stage. They're currently being tested in Sweden, and as each engine is qualified, it will be sent to Saxavord and integrated into the first stage. And then we can expect a hot fire of all 9 engines, which when they tried that in 2024 went wrong. We'll show you a video of that later on. But first of all, let's have a look at the other photos. There you can see the rocket, Saxavord, and there's one more. And you can see the crew around the rocket, and you can see the first and second stage. At the moment, there's no engines on the rocket, but that will happen over the next 2 or 3 months, hopefully. And then there'll be a launch sometime in summer of 2026. But let's read the article to get all the details. Bring the article up. Here it is. And this is on the RFA website. And I'll put a link to this article in the video description so you can read it yourself. I've highlighted parts of the article. Here it says first orbital launch planned for summer 2026. That's only 3 or 4 months away. So it goes on to say Rocket Factory Augsburg, or RFA, has delivered its first and second stages of the RFA ONE, that's the orbital class rocket, launch vehicle to Saxavord Spaceport in Scotland. And they go on to say there's been improvements to the Helix engine, that's the first stage engine, tank pressurization and operating procedures. And you'll see why they needed to update their operating procedures when we look at the anomaly video from 2024. So carrying on with the article, it goes on to say the causes of the incident during a hot fire test of a first stage in August 2024 have been fully understood and addressed. The first stage was newly built and tested in Augsburg, and the second stage was delivered to Saxavord in February 2026. The 9 Helix engines are currently being tested in Sweden and delivered to Saxavord on a rolling basis. The second stage has now been transported to the Saxavord Spaceport, and you can see the second stage at the top there. First stage is in the foreground and the second stage is in the background. So it goes on to say preparations are underway for the integration and further testing of the entire RFA ONE launch vehicle. Once testing is complete, the engines will be transported to the launch site and integrated into the first stage. The first orbital flight of RFA ONE is scheduled for summer 2026. So that is the article from the website. So that is the latest we have. So now let's look at the anomaly video from 2024 to see why they say they need to update operating procedures. So let's just watch it here. So as you can see, it's pretty spectacular failure. This was apparently just one engine that failed, but then of course the fire spread, destroying the other engines and causing the propellant to catch fire. And you do see some suppression, you do see water, but the water suppression system isn't strong enough to put out the fire. It's not scaled enough, and the fire just spread, and eventually the whole first stage rocket and all the engines were destroyed. There was some damage to the pad, but the pad is pretty robust, so it wasn't major damage. You can see the water there, but it's not enough to put out the fire. So it just gets worse and worse. And this was in August 2024, so this was 18 months ago. And there's been no testing at Saxavord since then. They've been rebuilding the engine, the first stage, the second stage. They've been making modifications and updating the operating procedures. Yeah, that's the first stage toppling down. So, and you can see the water flowing out, but it's not doing much. So anyway, that is the anomaly video, which is quite bad. They need to have a much more powerful fire suppression system that's able to put out the fire. They said they've updated the operating procedures. So now they've got the first and second stage of Saxavord. They're just waiting on the engines to be qualified in Sweden and then shipped to Saxavord, integrated onto the vehicle, and then a hot fire test, wet dress rehearsal maybe, and then they're ready to fly, hopefully in June or July or sometime in summer 2026. So that is the first story of this week, so let's move on. Okay, our next story is on Voyager Technologies partnering with Max Space for inflatable habitats on the moon. Now, I briefly covered this story already, but we have a new video, so I want to show you that video. But first we can read the update on X, and it says Voyager made a strategic investment at Max Space, the company's called Max Space, to advance the development of next generation expandable, that's inflatable, space habitats supporting sustained lunar operations and future deep space missions. This investment directly supports NASA's Artemis program and aligns with Administrator Isaacman's commitment to be on the moon to stay by 2028. So Jared Isaacman, the NASA administrator, has increased the cadence of the Artemis missions with an LEO mission in 2027. So that will be Orion docking with the human landing systems. And then in 2028, there could be 1 or even 2 missions to the moon. That's Artemis 4 and maybe Artemis 5. That will be sending a crew to land on the moon's surface if everything goes according to plan. They go on to say it also strengthens Voyager's broader lunar roadmap, spanning cislunar mission management, surface logistics, propulsion, and future surface infrastructure. The moon isn't a destination, it's an operational domain, and we're building the future to treat it that way. So we do have a new image, which is quite... So you can see an astronaut in the foreground, and you can see the inflatable habitats from Max Space and Voyager in the background. So you can see the inflatable habitat has Max Space on it, and you can see the metal area below has the Voyager logo. Voyager, via nanoracks, knows how to do airlocks. They have the Bishop airlock on the International Space Station. They're the prime contractor for Starlab, the commercial space station. So Voyager's know-how about airlocks and metal segments with Max Space's know-how about inflatable habitats, and you can get a moon habitat. So we also have some other renders. This is from Max Space. So you can see that you can actually put windows in the inflatable habitat, and you have solar panels on top. And there's another render. And we have an older render here as well. But in addition to that, we also have a video, which is a new video. I've not seen this one before. So let's just play it. I'll put myself in the corner. So you can see inflating on the moon, and then the solar panels, vertical solar array towers. Oh, and let's have a look. Let's have a look. Let's go back, because I saw a road. I do like to see roads. So it's not just putting the habitats. There are also leveling, compacting, grading surfaces to create roads for easy traversing across the lunar surface, which is very important. So carry on. So there you see another one inflating. And if we just go back a little bit, so you can see here there'll be an airlock here, and then there'll be stairs and a ramp. From the metal section, you can then enter into the inflatable area, which will be quite a lot of volume, potentially several hundred cubic meters of space. And you can see the solar panels. And then you've got a weird looking, that's very weird. Let's just have a look at that. That's nothing I recognize. I don't recognize that vehicle, that rover at all. So I think it's just for the video. That's not a lunar terrain vehicle I recognize at all. And what's that on the back of the... Oh, that's the life support system on the back of the astronaut's suit, I think. There you go. Oh, this is interesting. So go back a bit. So here you can see the habitats. There's a whole chain of habitats. They look like they've got tunnels, inflatable tunnels between them, perhaps. So they're obviously working on that kind of technology. So let's continue. And there's the astronaut, the selfie. Oh, okay, so that's the video. And we have an older video from Max Space about the inflatable habitat. So let's just show that. So access to space is limited. There isn't enough habitable space in space. And there's the inflatable habitat around Earth in low Earth orbit. So you just use a Falcon 9. It inflates to a much larger size. Ballistic grade debris shielding, 28,800 pounds of tensile strength, 69 psi burst limit. And it just inflates in space. And you can launch it on a Falcon 9. So it launches in a stowed configuration, and then it inflates in low Earth orbit. And you can use it on the moon as well. It's quite spacious inside. So this is a farm module. You could have a station around the moon or around Mars or on the surface of the moon. And there's a window as well. So that is Max Space. And I do believe they will be competing for NASA's Commercial LEO Destinations Phase 2 program. It's an open competition. Any US company can bid for the Phase 2 award, so you don't have to have been awarded money for Phase 1. We also have a article, and this is from Business Wire, so let's just read that. So the article says, Voyager's strategic investment in Max Space to advance permanent lunar habitat infrastructure. A multi-million-dollar strategic investment in Max Space to advance the development of next-generation expandable or inflatable space habitats supporting sustained lunar operations and future deep space missions. And we have a quote from the CEO of Voyager. He says, our investment in Max Space aligns directly with our strategy to deliver mission-ready systems that extend American strength into cislunar space. By pairing Voyager's integrated platform with Max Space's expandable habitat architecture, we are accelerating the transition from demonstration missions to durable lunar capability, unquote. And further down, we have a quote from Salim Mian, who is a co-founder and CEO of Max Space. He says, Max Space was built to solve the hardest problem in lunar exploration, delivering safe, scalable, and permanent human space at an economically viable mass. And then he goes on to say, together we are building habitats designed not just to reach the moon, but to stay there, unquote. And the article goes on to say, directly supports NASA's historical Artemis program and aligns precisely with Administrator Isaacman's announcement to be on the moon to stay by 2028. Max Space delivers critical enabling infrastructure, maximizing livable volume, enhancing crew safety, and reducing the cost and complexity of surface deployment. So that is the article from Business Wire. So at the moment, NASA does have a plan for a habitat on the moon. It's called the MPH, or Multi-Purpose Habitat. It's been developed by the Italian Space Agency and Thales Alenia in Italy. So this will be Europe's contribution to the Artemis program. But it is a metal structure. It's quite small in volume. So it would be good to have other alternatives or other options to expand the Artemis base camp, or for a scientific outpost away from the main base camp. So let's move on to our last story this week. Starlab and Yuri partnering together. So Starlab is a consortium of companies working on a commercial space station design. The companies are Voyager Technologies, which we just talked about, Airbus, Mitsubishi, MDA Space, Palantir, and there's a few others as well. So it's a big consortium. They have a lot of money and they're working on a quite large space station. I've done a video on them already. Refer to that video for all the details. But let's just read what they say here on this X post. Yuri GmbH, so it's a German company, has reserved payload space for the entire first year of Starlab space operations, marking a major step towards sustained scalable life sciences research and manufacturing in microgravity. This dedicated capacity will support continuous experimentation, bioprocess development, and in-space biotechnology production, moving beyond short-term missions to reliable, year-round commercial activity in low Earth orbit. Together, the companies are helping shift space research from episodic access to persistent infrastructure, building the foundation for a global, sustainable space biotech economy. So that is a post from X. So we have a photo of the Yuri payload. So this is a research station of some kind. And Yuri have been sending payloads to space for some time now on the International Space Station, I believe. And they also have payloads, if we have this one, going to the Haven 1 space station by Vast Space. So it says here, Vast, Yuri. Yuri Science Taxi is a life science incubator and centrifuge that will be installed in the Haven 1 lab. And we have another graphic here. This is from Vast Space. So Vast Space have 10 payload lockers, or what's called mid-deck locker equivalent size. 2 of them are for Yuri and Redwire, and I believe 5 or 6 of them are now filled. So Vast Space's Haven 1 should launch in 2027. So in addition to Haven 1 and now Starlab, they were working on a project between 3 different German companies. The project was called EVA, and that includes RFA, Rocket Factory Augsburg, which we've talked about already. Yuri providing the science, payload, and Atmos providing the inflatable atmospheric decelerator technology, which has already been demonstrated on a SpaceX transporter mission, at least a subscale version. So they're working on a full-size version, and I think we have another graphic here. So basically, the RFA ONE orbital rocket would launch with a space tug called Redshift, and that would include a Phoenix capsule, again from RFA. You'd have the Atmos inflatable atmospheric decelerator, and inside you'd have the Yuri payloads to do science. This goes into orbit, and then the science taxi payload from Yuri does its work, and then the payload is returned to Earth using Atmos's IAD, or inflatable atmospheric decelerator. So that's one project. Another project is using the Nix vehicle from the Exploration Company. So their vehicle is called Nix, and inside that you could have the Yuri payload. This has been proposed as well. So you can see the capsule here, and then the Yuri payload goes in the center somewhere. And Nix is reusable. It comes back to Earth. There's parachutes deployed, and then it lands softly in the ocean, and then you can recover the Yuri payload. That's a number of different projects that Yuri is working on. We'll see how all those projects from Yuri develop. So that is the space news for this week. In terms of what I'm doing next, I'm not sure. I haven't really decided. So maybe something to do with the moon, but I have not decided yet. So what do you think about the news from these companies? Please leave your comments below, and potentially I'll read them out on the live stream at the weekend. So see you on Friday.